Okay, let's jump right into this. Welcome to this explainer on refactoring CLI verbosity for better type safety in Haskell. Today, we're taking a look at a really fascinating code makeover based on insights from Notes on Haskell Programming by a developer named Ang. We're going to see exactly how to transform fragile, integer-based code into a rock-solid, self-documenting system using Haskell. But first, I want you to think about this. Is your code secretly relying on fragile magic numbers? We've all seen them, right? Those ambiguous integers lurking in a codebase. They're basically like unlabeled dials on a giant machine. You might know what they do today, but a year from now? Yeah, good luck. It's a total guessing game. Well, today we'll explore how to upgrade those unlabeled dials into explicit lock and key safety mechanisms. Section 1. The magic number problem. You know the drill. You're tracking command line verbosity flags, typing -v, -vv, or maybe -vvv, and traditionally, you just store that as a plain integer, usually counting from 0 to 3. But here's the massive architectural weakness. Tracking these flags as a raw integer creates a fragile magic number. Having a random 2 sitting in your config is incredibly hard to read because it completely lacks semantic meaning. It forces anyone reading your code to just guess what 2 actually represents for logging. Moving on to Section 2. The algebraic solution. So to fix this structural fragility, we need to ditch the raw integers. Instead, we define a custom algebraic data type called verbosity. And rather than relying on 0, 1, 2, or 3, we literally spell out the explicit levels: quiet, normal, verbose, and debug. And because this custom type derives properties like enum and bounded, we instantly get these clearly labeled options scaling sequentially from least to most verbose. We're literally baking the actual meaning straight into the type itself. Which brings us to Section 3, safe parsing and clamping. Now that we have our custom type, we need a robust parser. The new Verbosity option parser handles this beautifully in 2 clean steps. Step 1, it counts the repeated -v flags. But hey, what if a user just playfully mashes their keyboard and types like 5 -v flags? That's where Step 2 steps in to save the day. It safely clamps the result to our maximum bound, which we explicitly defined as debug. It mathematically prevents the value from ever exceeding our highest defined state. And looking at this comparison, you can really see why that clamping is an absolute game changer. On the top, the old method using unbounded integers was constantly risking invalid range errors. Too many flags and the system might try to access a verbosity level of 5, which doesn't exist, leading to undefined behavior or a crash. But on the bottom, the new type-safe method fundamentally prevents out-of-range values. By safely clamping to a maximum value, it acts as an unbreakable ceiling. Let's look at Section 4, self-documenting mapping. Check out the incredible contrast in readability here. On the left, we have the old integer inputs. We've got a 0 mapping to an error, a 1 mapping to a warning, and this wildcard underscore catching everything else for info. It's kind of cryptic, right? Now look at the new verbosity inputs on the right. This is the beauty of the refactor. Quiet maps to error. Normal maps to warning. Verbose and debug map to info. Instead of vaguely mapping abstract numbers, the mapping is entirely explicit and self-documenting. And the best part? This readability isn't just for the main code. It cascades perfectly into your automated tests. Look at the test output strings here. The old string reads, parses VVV as verbosity 3. The new one reads, parses VVV as debug verbosity. A developer reading a failing test doesn't have to do mental gymnastics anymore to remember what verbosity 3 stands for. The test tells them immediately, in plain English. Finally, Section 5, why type safety matters. So, let's zoom out and look at the big picture. Because your functions now demand an explicit verbosity constructor instead of some ambiguous integer, the entire codebase becomes undeniably cleaner and way more readable. And as a direct result, the system becomes incredibly resilient to bugs as the project grows. You aren't just hoping another developer passes the correct integer, the compiler is actively enforcing it for you. I love how Ang sums this up in their notes. They point out that this type safety upgrade makes it, quote, impossible to accidentally pass an invalid logging level. I mean, that right there is the gold standard of refactoring. We didn't just make a bug less likely, we used the type system to make that specific class of bug literally impossible. So I want to leave you with this final thought. Take a hard look at your own codebase today. Where are the magic numbers hiding in your own projects?
What fragile, unlabeled integer is just sitting there waiting to be replaced with a rock-solid algebraic data type? Make your code self-documenting, make your invalid states impossible, and let the compiler do the heavy lifting. Thanks for joining me on this explainer, and happy refactoring.